Hi, it's Gadget UK here again. This time looking at a couple of different Nintendo 64 power supplies. So I'm following on here from a video that Vince did, my mate Vince. Check Vince's channel out. I'm sure you've seen Vince before. If you've not, you are missing out on one of the goldenest repair channels that exists ever. It is just the bestest channel to watch, seriously. I get so much enjoyment and learn so much out of watching Vince's videos. He took a few of these to pieces, I think, certainly one of them that I remember, and he found a common fault, and I think that's the fault with one that I looked at years back, and I've still got the PCB because I actually stripped it for spares and actually converted it to use a buck converter inside there, you know, a DC to DC. I could plug a 12 volt, in fact I had a permanently wired in 12 volt cable, 12 volt power supply, and I put a few capacitors and things, and I might show that within this video as well, because I get lots of questions on that video, like how did you wire it, where did you put the caps, etc., where did you put the fuse. I put a few different things in there like that. Yeah, and I get asked that all the time. So anyway, to get inside this we need one of the game bit things. I'm going to have a look at this before I even power it up and attempt to use it. It's faulty, described as faulty. Yeah, so here comes the iFixit toolkit again, but we don't have an iFixit bit, which is why I've got these two game bits here. Is this one going to fit? And I think it's game bit, I'm pretty sure it is. There's generally two sizes you need, the larger one and the smaller one. The smaller one is used for carts, the larger one is used for things like this, and if we just get that into position, God, that is tight. Obviously don't go inside this when it's plugged in, make sure it's unplugged, and capacitors can hold mains level voltages, you know, and higher, you know, 337 volts approximately DC here in the UK. So let's just see, is this the same revision first of all? Just get that out and pull that out. It is, and I reckon this has got the same problem. So what Vince discovered was this mastic here, through heat and temperature humidity changes over the years, it starts to conduct, I think, and it kills one of the little SMD components here. Yeah, and that's all he had to do. I mean, he did a lot of work to get to that conclusion. I mean, the capacitors even look good. These don't look like they've leaked, so I don't even think it needs recapping, to be honest. So I'm going to start by putting this back in there now in the case. We'll measure the voltages. If there's no voltages, the first thing I'm going to do is clean that off there and measure around this point. Yeah, so I'm measuring the voltages on my knee here. Yeah, this is not screwed together, this case. I believe the ground is like that one there, and just getting the probes, you know, these sharp probes in there, and just checking all the combinations. We've got, you know, 0 volts on every single pin. So actually this one might have a different issue, because we've just got no voltage there at all, completely flatlined. So let's just start by checking the fuse actually. So let's just get that fuse out of there. Assuming it's got fuse in it, someone might take, no, it has got fuse in it. 3 amp. So you never know, there's a chance that might have blown. Wouldn't it be nice if it was that? I'd rather it wasn't actually, I'd rather it had the same faults that Vince demonstrated. Yeah, so that fuse is alright, but there's a fuse or two, I think, on the board. Now remember, we've just had this plugged in, so you know what, we could have some higher voltages in those caps than we had before. So I just need to be careful I don't give myself a shock from this. Yeah, we have a fuse here, I think it's, is it 1.6 amp? Let's just have a look. Yeah, it's 2 amp. T2 amp, that fuse is marked, so let's just flip it over and see if we can measure its contacts. Can't see where it is, it's here. Actually, that fuse is blown. No, it hasn't. Yeah, you've got to make sure you've got a good connection there. So I think before I do anything else, because the fuse is alright, both the fuses are okay, I will inspect around this, and obviously we've got some fuses on this side as well here. We've got those two there, fuses, so we can check those. Let's just make sure those aren't blown. Yeah, that's alright, and that's alright. One of those is going to be on 12 volts, one of them is going to be on the 3.3. So you can see what I can see here through the microscope. So I'm just going to carefully try and massage this out of the way. It's awful stuff, it really is. Some IPA will help get this off. In fact, let's just do that. Let's just get some IPA on a cotton bud. I mean, it kind of looks like silicon, doesn't it? But why is it grey, you know? Well, it's grey silicon, but maybe it's not. It's just interesting to me that this would cause this problem on some of these. And the other thing in relation to that on Vince's video is, I mean, it proves that when I did that other one where I ripped out its innards, I actually traced it to this PCB. I'm like, it's this comparator. There's something wrong with the comparator circuit. And I spent ages checking everything. I just somehow missed checking the component that I think Vince worked out was the one. And it's just in this corner here. It's one of these. Oh my God, that's hard to get off. I'm just going to grab it with the pliers here and just try and sort of pull it out like that. There we go. Those don't look so clever. And obviously we've got something on this IC, so you know what, in my case here, maybe this IC's gone. It might be a different fault. I'm just going to rub around there with the cotton bud on IPA. Let's just get a bit more focus. Just see if I can rub off whatever's there. Probably not. Yeah, it's like well and truly stuck onto that, isn't it? I mean, if that IC was the issue, I think I've still got the old one off the old board. The one I did something with. See, that's corrosion there, isn't it? This is it, or is it? Is it just some of that stuff, or has it joined those two traces up at some point? Now that is corrosion, look. It's kind of greeny. So that might be the issue, you know, it joins these two traces up here, look. Just get another cotton bud with some more IPA. So it might not be that it's overheating this, because it was one of these here, it was like that there on Vince's. I actually think it's these traces that join, because we can see that where I just wiped that bit. Yeah, so I zoomed in a bit closer there, and I used the cotton bud with the IPA and removed the stuff off that. So those are looking okay. They look a bit shiny, those, don't they? It was one of these that was faulty, I think, that Vince identified. But, you know, we saw this bit here, can you see? There. There was like a bridge of something between those two. So, you never know. Maybe this is faulty. I need to check these, and we'll check these, because I think it was this one on Vince's. I can't quite remember now. I've still got some more of that silicon stuff there, a little bit up there. And obviously, you'd really want to take this to pieces further, you know, to get maybe all this off up here, maybe. Anyway, I'm going to give it another try, just see has that made any difference, just removing that. Yeah, so still not doing anything. I've just measured these two components here. The bottom one is 1500 ohms. The top one is just showing open circuit. You know, OL, open line. So I think that's what the issue is. I think it's the same thing again. But I don't know whether that results in zero voltage. It may do. It may you get some voltage and it cuts out if it's reduced in resistance. But when it's completely open circuit, maybe you get nothing. So I'm going to go and remind myself of what size that should be. And the way I'm going to do that is from Vince's video. And then I'll go find that the PCB, the one I kept here, and we'll measure the one on that. And I think I've done that already, and it was open circuit on mine as well. And then we'll just see. We'll swap in that out with a resistor, fix it. I don't know. Watch this space. Yep, thanks to my mate Vince, worked it out, 220 ohms. He was kind enough to mention that on the video. The funny thing is, Vince said, if you look at the top of the resistor, you can see 221. I can't see 221, it's like so small, even with a microscope. And I've got the same microscope. So, I don't know, mine are awful, my eyes. 220 ohms, so I just need to see if I can find, amongst all my spare million resistors here, 220 ohm resistor. Yay, got some 225%. Yeah, they're about the same size as the ones that are on. So I'm not even going to take this to pieces. I'm going to do the lazy man's approach here and try and smudge that out of the way with my iron. Just like that, you know, rather than spend the time taking the board out and disassembling it and everything, because you've got to unscrew a few things. There's some things soldered here, there, I think, yeah, and then the screw. It's just far easier if we can just squish that one resistor out the gap here And I'm going to bring the iron in, and I'm just going to, like I say, just try and bodge this out of the way, really, by alternating, you know, one side. That side there feels like it's absorbing loads of heat. Yeah, easier said than done. I'm going to feed the solder with my left hand. There we go. So I've got some solder on there. I think what I might try and do is just sideways like this, bring the iron in, and then, hang on, I've got to be careful what I'm touching because I'm not actually watching the wider area with the iron. Nope, it's that way I want to go, not that way. That's it, you sort of heat and then pull. I'm just going to get a load more solder onto the tip. Yeah, try that again, just try. Heat both sides at once, there we go. Yeah, this is what you have to do, a lazy approach. That's it, it's off. Get rid of it onto the sponge. You can see we removed that bit of solder, so I'm just trying to get one of the resistors out. Yeah, I seem to lose that, it seems to fall on the floor, so let me get another one out. If you struggle to get something like that into, hang on, where's that thing gone there, position, just wet your finger and touch the component. Look, you see it's a bit big, this. Oh my god, it's now stuck to the tool through magnetism. Can't get rid of it. I literally cannot get rid of that now. There we are. So I'm going to try and attempt to just solder that one side if I can. And I'm going to touch the silicon a bit here because we're sort of in that position, aren't we? There we go. And if I just sort of get here, touch that. Yeah, you see, look, it's not joined, is it? And now we've got magnetism thing going on again here. Oh, that's it. So let's now just try coming in up, down there. I'm going to use this metal prodding tool here at the same time. Just try and heat the point there and just line it a bit. Remember, this is the lazy approach. And of course you're going to get a better result with a bit of hot air. That's for sure. Press it down. Heat that point. Up. Try and give myself enough space. There we go. So it's secured. Try and give myself enough space there to solder that on. I do wonder where that other 220 ohm resistor went. Hang on, which way is it? That way. So let's plug that in. I'll sort of hold it on the bench. It's not screwed together, this. Yeah, this is not the safest way to test power supplies between your legs. But anyway, let's just go for it. So I think that's ground up there. And I think down here. Oh look, we've got 3.3 volts, that's it. That was the fault. It's working. 3.4 is about right. 3.4, we should have like 12 or something down here somewhere. Yeah, 11, it's a bit low. But that's it, that's fixed. Vince has helped us fix it. So, I'm not even going to recap this at this point, I'm just going to get the screws back in and we'll go and test it. And let's just connect it up. So it goes like that. There we go. And it's switched on the floor, I think there. So if we now switch this on, hopefully power LED. Hey! That's it! That was the fault. So, absolute amazing work, Vince. It is a common fault. This is what probably kills most of those power supplies. And I can confirm that by, well, having a look at the next one, but also, I think, showing you the PCB from that one I talked about earlier. Anyway, I'm going to connect up the cables and things and just make sure it does actually work. But that was so easy to fix. So, if you're watching this, Vince, many thanks. You're probably going to be helping save hundreds of these. So the final thing you might want to do to something like this is recap it. You know, replace those electrolytic through-hole caps. See if we can skip past this. I don't think you can actually, you've got to watch it, haven't you?
Your mission is to rendezvous with that convoy and escort it to the landing zone. Good luck.
Got the 4 meg RAM pack in this, so it's, you know, it's running a higher res mode, I think. It looks sharper.
Luke, we've already got stuff. Real good. Take your targets and go.
Fantastic.
Good shooting.
I crashed into that one, didn't I? Right, so here's the next power supply. This one's nicely in this bag. Well, I'm going to have to rip it. I'm going to try to seal it, I think. What do you think is going to be wrong with this one? Do you reckon it's going to be the same fault? It might be a different revision. It may have a completely different fault, but I don't know. I'm calling it now and saying this is going to have that 220 ohm resistor need replaced, isn't it? Yeah, the screws were incredibly hard to get out of that one. Really, really hard to get out. So let's just take a lid off. This hasn't been plugged in. Yeah, looks like the same revision again because it's got the little solder points there, I think, for the same little comparator board. You know, that's the thing that has a comparator circuit on there that adjusts the switching frequency and stuff and cuts it off depending on what the voltage level is. And look, there's that grey stuff again. So let's just remove it and measure that resistor and replace that resistor. That's going to be it, isn't it? Yeah. It's pretty hard trying to hold this on the bench and do it all at the same time, so I'll get some solder there, a huge blob look. Just try and scoop it out. There we go, it's gone. So that's that bit done, so let's just bring the braid in again. We'll do exactly the same thing we did before. So far, this has been like 2 minutes. 2 minutes of work, I think, to get this working, I reckon. I didn't even measure it, did you notice that? Sorry. I am cutting corners now, because that's going to be it, isn't it? I'm convinced of it. You never know, it might not be. It might be a fuse or something, anything on this one, really. I'll do the wet finger technique again just to get that on there. Yeah, try and do that. Then use my little metal tool. Yeah, I am sort of trying to balance this at an angle. There we go. Use the tool in the left hand here, and then the iron in the right hand, just so I can get that about there. I'll do. Get the solder there in the right place, and the iron down. Oh, there we go, sort of done that thing. A little bit there. A little up. Overflow there. Oh, the solder on the edge there. That'll do. Let's see. Looks there. Get the solder off the tip. He says, and then the solder on the tip. And then do that side first, I think. Sorry. That's it. So we did get some solder on the edge of that metal thing now. I need to just get rid of that. Make sure it doesn't fall off. If we just try and clean there, you can see that solder there. I've just chipped it off, you saw it, it went flying to the right. And we did touch that, no we didn't. Yeah, we did just touch that edge. Just a little bit. Let's just see if we can squeeze that in there like that. That's it. There we go. So let's reassemble it and give it a try. Put the socket on. Didn't bang. It's not screwed together again. And obviously we didn't measure it at the start, but I know this was sold as completely faulty, dead. So let's do exactly the same thing. Ground. Oh, and it is dead. Oh, hang on, it's not switched on. Yeah, there's me thinking it's dead. When it's not dead, we know Vince has fixed it. So there we go, that's another one, 2 for 2. That one took me literally 5 minutes to fix. The 12 volts is slightly higher on that one, but this is what you find on these. The 12 volts you'll measure and it's like 11 volts, and you may find it goes up a bit with the load, but there's very little drawn on that line. I think it's used for the GPU or something, I don't know, for the video side of things. Anyway, that's good, so we'll test that one as well. Yep, and that one works as well. So very, very pleased. Let's just load this version of main. It doesn't cover very many games, but it just allows you to play one or two of these old arcade games. Where's the thing on? Bomb Jack, I didn't know that was on here. That's quite cool. It might not be very fast, the music might not be there or the sound, but nevertheless, let's give it a go. There we go, I'll put credit. Yeah, there's no sound on this one. That's the problem with this version. There might be a newer version of this, I don't know. Nevertheless, it's quite cool being able to play one or two main games on the N64. Let's try Resident Evil 2. It's quite reduced compared to, say, the PlayStation version. You'd have had to trim down the quality of the video and the audio and stuff. I always thought it was impressive they managed to put Resident Evil on a cartridge like this, because they were not very big, were they? It was about 32 meg or 64 meg or something, not very big at all. Yeah, so like the FMV and stuff has been compressed and reduced down and stuff, quality-wise. But I think it's a pretty good version of it. It's got everything there, really. Just the FMV and audio is just reduced in quality slightly.
The Raccoon City Police Department, Special Stars, immediately began.
Yeah, you do start with a gun here, don't you? Oh, the zombie's got me. Right, so here is that board, what's left of it, from the very first repair I did, and it's this one down here, isn't it? So if we measure the inner one first, that should be 1500, or is it? Ohms roughly. Hang on. Is it 1500 ohms? No, that one's open circuit. Ah, this explains the difference in behaviour. So you can get one of two different failure modes here. I think when Vince had it, it was completely dead, and that's where you get the 220 ohms here. So the 220 ohm goes open circuit. We don't have that in that first one I had, which is why I was chasing voltages, yeah? And what I mean by that, I was measuring 3 point something volts, and it was going on, off, it's cutting in and out, cutting in and out, cutting in and out, because something else was wrong here, and it's actually the other component. So where, you know, that one there, I think is supposed to be 1500 or 1.2k, and that one's open. So it's still the same area, and I do still think it's heat, it's not actually conductivity that causes this. Because if you look at the size of these things are tiny. They're like a grain of salt size. So how does that relate? Well, it relates to the current that they can pass. You know, you've probably got like, I don't know, 1/16 of a watt, or maybe even less, maybe a 32nd of a watt or something. Is that the right way of phrasing that? 32nd part of a watt. The reality is though, when you get a bit of current going through there and it gets hot, well, if you've got nowhere to dissipate the heat because it's in a big blob of silicon mounted to the heat sink with a transistor or something next to it here, yeah, it's going to fail sooner rather than later. But the bottom line is on mine here, my original one, it's not the outside one, it's the inner one. And the outside one is measuring 220 ohms, 230-ish. And the other thing that could be an issue here is that little IC, because a lot of the time I've seen that underneath that silicon as well, so you know that could fail. But it seems to be primarily those two resistors. So massive thanks to my mate Vince, it is definitely a common fault. Technically we've got one here that, had I been able to fix that back in the day, that would be that one. And then we fixed two in this video here. Yeah, you do want to recap these though. I wouldn't, you know, sell them or whatever that way. It's worth just changing the 3 or so capacitors in there. whilst you're at it. Do check out Vince's video. You will pick up so many techniques, not just across things like this, but all sorts of home appliances. I mean, everything from, you know, like yachts, ovens, I don't know, food blenders, hi-fi, CD players, mobile phones, laptops, netbooks, you name it, toys, all sorts of things. Vince covers everything. Anyway, thank you very much for watching. I will catch you in the next video.